Hey class, today we're going to continue talking about the real number system. So we remember the real number system is a way for us to just see how the different numbers we interact with can relate to one another, whether they're natural, whole, integers, rationals, irrationals, all that fun stuff. So we're actually going to talk about two different things today. We're going to talk about how we can categorize groups of numbers within the real number system, and we're also going to talk about operations between real, or not real, rational and irrational. So let's just start with a review of how to categorize these numbers. So I know that 0, it is a rational number, it is a whole number, it is an integer. Pi, because pi is a decimal that goes on forever and does not repeat, that is going to be irrational. The square root of 25, be careful. I know we talked about the square roots, but because the square root of 25 is 5, that's going to mean, one, that it's natural. I'm just going to write nat. It's also whole. And again, because it's a natural number, we can look up at the diagram up here. Because it's a natural number, I know it's going to be a whole number because that circle is inside the other circle, which means the whole number circle is inside the integers and rationals as well, which means it's going to be an integer and it's going to be rational. And lastly, we've got the negative 1/2. So it's not natural, it's not whole, it's not an integer, but it is rational. And in case we forgot, I can write, well, first it's a ratio anyway, it's a fraction. But I could write that as something like negative 0.5, and that's a terminating decimal, which means it's going to be rational. So we can use that same thought process to go through this group of numbers as well. So we're going to start by categorizing each individual number, and then we're going to see what they have in common. So 0 is a whole number. I'm just going to use the initials to make it a little easier. 0 is a whole number. But because it's a whole number, I know it's an integer. I know it's rational. Negative 10 is not a whole number, but it is an integer, and it's rational. This is a ratio again, which means it's rational. And then square root of 36 actually equals 6, so that's kind of all of them. So if I look, they all have one thing in common. They all have rational. So because that's the most specific subset, all of these numbers can be categorized as rational. I can do the same thing with this set of numbers. I'm going to go through each one. I'm going to categorize them individually, and then I'm going to compare those and see which ones they have in common. First up is rational. Next, I've got integer and rational. 2/3 is just rational. 4 1/8 again is just rational. If you're ever stuck, if you see it as a fraction, that means it's going to be rational. And then lastly, 9 squared is really 81, which means that's a whole number. It's natural. I don't know why I wrote those backwards. It is an integer, and it is rational. So again, looks like all of them are going to be rational. I'm going to write an R, and they are all rational. So again, the idea is that you're starting by figuring out what they are individually, and then you compare and see which ones they have in common. Next, we're moving on to operations within the real number system. So that's basically saying, well, what happens if I actually add them and multiply them? Am I going to get the same number out? So let's start with thinking about what happens if I take a rational and I add a rational. If I take any rational number and I add it to another rational number, I'm going to end up with a rational number. Same thing if I subtract them. If I do a rational minus rational, still rational, doesn't matter. And you could try this with any two numbers. As long as they're rational, if you subtract them, you get rational. Next, since we did plus and minus, we're going to move on to multiplication. Rational times rational is going to get us a rational as well. And then if I divide, as long as they're not 0, right? I can't divide by 0, but as long as both my numbers are rational and I divide, I'm going to get a rational number out. And then again, a helpful tip here would be that if you use Desmos, it'll definitely give you an answer as well. Next, we're going to combine them. What happens if I take an irrational and a rational number? So let's say, what happens if I do rational plus irrational? Well, because that irrational part has a decimal that goes on forever, if I add it to a rational number, that decimal part is going to make it become irrational. Same thing if I subtract. And the order doesn't matter here. I could have easily written I minus R, but the point stands, if even one of them is irrational, the whole thing is irrational. Same with if I multiply. Rational times irrational. I'm going to get an irrational number out. And then if I divide as well, I'm going to get an irrational number. So, based on the above chart, you can kind of see a pattern. If one of those is irrational, no matter what, if one of them is irrational, so if you combine a rational with an irrational, you're going to end up with an irrational number. So again, two rationals, you get rational, it's cool. But if you combine them and do irrational plus rational, or irrational times irrational, or irrational times rational, you're just going to get irrationals out. So what I would like you guys to work on your own, again, you are going to classify these groups of numbers. You can use these categories up top here. And then I also would like you to tell me if these problems are going to be rational or irrational. And I'll give you guys a hint. The very first thing I would do, and I guess I could do number one for you real quick, just figure out what these are. So I know that the square root of 225 is 15. So this is basically saying I'm taking a rational number and I'm multiplying it by an irrational number. Based on that, if I scroll back up to the chart, it's going to tell me it's irrational. So I would go through each one. I would write if it's rational minus irrational or rational minus rational, whatever, and then look up at the chart.